to 1.6, solve linear equations containing decimals. Nothing changes in this section. It's just, what do you know? We're going to see some decimals. That's it. But the principles of equality, they stay. There they are, principles of equality. Just whatever you do to one side, you can do to the other side. It can be negative, it can be a fraction, it can be decimal, it can be whole value. Doesn't matter. You can use addition, subtraction, multiplication on both sides. No problem, okay? There we go. Yeah, but those are big numbers. Well, I mean, there's lots of digits in the numbers. But it's doable, right? Especially, what do you know, with a calculator. I'll do this one with without a calculator, but pretty much after this, I'm going to be using a calculator. This one, by the way, is a one-stepper because that coefficient of x right now, it's already a phantom 1. And that's what I want. So I'm going to bring this down because that's what I want. I just want to get rid of, and that means zero out, that 29 and 478 thousandths. Yeah, that's the technical word for it. Or 29.478, whatever you want, okay? So how do I get rid of it? It's positive right now, so just subtract it from itself, 29.478. So subtract over here, 29.478. I didn't line those place values up very well, but that still works. And some of you guys are like, well, how are you going to do that? Well, I know it's going to be negative, first of all, for those of you who take like 900, 950. That's the first thing I do. I'm taking away more than I have, right? So that's going to change that into, I know I'm going to have a negative value. Now I'm just going to take the bigger of the two values, 29.478, and then subtract my 12.84. Like, if you're not screaming for a calculator right now, I worry about your mental health. But in any case, 8. I got to start with the place value farthest to the right. 8 minus 0, 8. 7 minus 4, now that's a hundredth, 3. Now the tenths, I'll have to borrow 1 from the 9 to make that 8. So 14 minus 8, and that should be 6. And then in the ones place value, 8 minus 2 is 6. And then 2 minus 1 in the tens, 1. So it looks like I end up with negative 16.638, or negative 16 and 638 thousandths. I don't really need that phantom 1 there, or that 1 there, so I'll make it a phantom 1. It's a great question. So let's say that on this one it said, hey, round to the nearest hundredths, or 2 decimal places, right? So that's a 3. And for those of you, like, if you're not familiar with rounding, just go to YouTube and type in rounding song. And you can find it with rap music, I think country music, and then Elmo. So that's not an insult. It's just out there, okay? So you can find it out there. It's like, I don't even remember. So here's what I'm going to do. For me, I underline the place value I'm looking to round to. I go to the place value immediately to the right. It's 8. If it's 5 or more, then I add 1 to the place value that I'm rounding to. So that's 8, which is 5 or more. So I add 1 to the 3, and so I'd end up with a 4 in that hundredths place value. So this ends up just being negative 16.64. If it were less than 5, I would have just kept the 3 the same. Everything else to the right becomes zeros. So I don't really need to show this as 0.640, of course, but it's just 0.64 at that point. That is only if it wanted us to round, okay? Remember, principles of equality here, and in fact, this one's only a 2-stepper, so I should only need 2 principles of equality to solve this one, okay? Now, remember, our objective is to isolate whatever the letter is, in this case, p's, right? So I got 2.4 p's, and it doesn't matter if there's a decimal. The principles of equality will stay the same. So it's that negative 6, stinking negative 6. I got to get rid of it, and by get rid of, I mean zero it out, right? So add 6, but if I do it to one side, yeah, got to do it to the other side. Okay? So once again, my recommendation is to put that into the calculator. Negative 8.7 plus 6.0 should give you negative 2.7 right there, okay? And then I'll drop my 2.4p, that's positive because of the plus sign. So I get 2.4p equals negative 2.7. Now I'll divide both sides by 2.4. So a couple things, and I know I've covered this, but I just want to emphasize it more. Why am I dividing? It's because I want the coefficient to be a 1. Right now it's 2.4p in black. I don't want it to be 2.4p's, I want 1. How do I make a 1? With division. Anything divided by itself will be 1. And once again, I cross this out with a 1. It's not just crossing it out arbitrarily there, okay? So it's 1p. Again, this one right here, though, I'm going to make it a phantom 1. It's there, you just can't see it, and that's what makes phantom values kind of creepy. But in any case, I got negative 2.7 divided by 2.4, and when I put that in my calculator, it gives me, because we do want the decimal, by the way, negative 1.125. Okay, so I'm going to check, I'm just going to use the calculator to check this, right? So negative 6 plus 2.4, and we can type it all in at one time, negative 2.4 times negative 1.125, enter. Now when I push enter, or before I push enter, I should expect it to show negative 8.7. I did push enter, and it shows negative 8.7, which means that I now have a true statement, okay? And that means that this is the actual solution to our equation. So, here we go. Let's change this negative 2.7, because I'm doing it particularly this way because it's not that bad, but I'm going to move the decimals, both decimals once. Really what I did is multiplied both the numerator and denominator by 10. I scaled the fraction, which then makes this negative 27/24. And then that would be, it's simplifiable into negative 9/8. Or negative 1 1/8, or negative 1.125. 7m minus 3.4 equals 5.8 m plus 6.12. All right. Well, I'll do this one together. Okay, we'll give you a chance to try the next one on your own. But principles of equality, and once again, I'm going to take a little bit of a shortcut on this one and just do two principles of equality in one line. So you know what? I'll give myself more space here, like this. All right. But by the time I finish this with putting both principles of equality into one step, then it's just going to save me space, and it's going to narrow this down into pretty much a one-step equation right off the bat. All right. Now for me, once again, I do like my variables on the left and the numbers on the right. Do you have to do that? No, you do not. But the 7m, it's on the correct side. So it's that negative 3.4. I got to zero that out by adding it to itself. Well, adding its opposite. Yeah. Negative 3.4 plus 3.4 is 0. But if I do it to one side, yep, I got to do it to the other side. So plus 3.4. But you'll notice that I have aligned that with the 6.12. That's because those are like terms. I would definitely not want to put the plus 3.4 below the m term because they are not like terms to combine. So what do I get from that? 6.12 positive plus 3.4, 9.52. Seems like an unusual number. But now the m's. I got 5.8 m's on the number side of things. That's got a 0 out. So let's subtract 5.8 m's. Why subtract? Because it will 0 out. But if I do it to one side, I got to do it the other side as well. So minus 5.8 m. So 7 m's minus 5.8 m's. Yeah, 7m plus, minus 5.8 m's. I get 1.2 m's on that. And so, yeah, see how this becomes a one-step equation? Do you have to do that in one step like I just did, like in one phase, or, I don't know, upside down T, whatever you want to call it? No, you do not. You could have done it in two steps like I've been doing with the previous problems, right? It's just now, what are we going to do? Divide both sides by the coefficient, 1.2. That rhymed, but not on purpose. So there's our phantom 1. 1m, phantom 1, equals, oh, I'll use a calculator for this one. Where's my calculator? 9.52 divided by 1.2, or over 1.2, either way. Oh, yeah, this is pretty ugly, right? I got 7.93333, and then some people show that the threes repeat like this. Other people, known as math nerds, show it like this. It's called bar notation. Would it ask us to round this one? Probably. And probably to 2 decimal places, right? So maybe it would be good to see more of those threes anyways. I would only need one more 3, but you could say lots of them. As many as you want, by the way, because this goes on for infinity. But let's say we're going to round this to the 2 decimal places, right? So that's this 3. Again, I circled one to the right. That 3 to the right in the thousandths place value is less than 5. So this 3 in the hundredths place value, I just keep the same. And I end with m, after rounding, equals 7.93. Okay, so let's go back to that 7m. And we only need to focus on the numbers here, the coefficients. I would make this 7.0. And then I would subtract 5.8, okay? Just so I have numbers to line each place value up with. And yeah, I have enough to take away 5.8, so I don't need to worry about any subtraction rules or like changing it into addition problem. But there, I got 0 minus 8, that's not enough, so I got to borrow 1 from the 7. So I'm splitting the 7 up purposefully and meaningfully into 6 and 1, right? That's how many tens I'm looking at, 6 tens and 1 10. Well, the 1 10 I just transfer over to the ones place value. 10 minus 8 is 2. The decimal just drops down, by the way. And then 6 minus 5, boom, 1. And then, of course, that was in M's. Yeah, if you do it by hand, again, that's the step right here. So solve this one, principles of equality, distribution, and combining like terms too on this one. That's very nice. So let's move this up here. Give ourselves some space, right? Well, some distribution. So I got to distribute my 0.5 into the set of parentheses. At 0.5 times 0.25, which should be 0.125x. Don't forget your x on that, by the way, because I almost did. But 0.5, this would be 0.5 times negative 2 there, which would be now negative 1. Hey, that's not too bad. And then I'm going to distribute this. That's a negative 0.125. Got to remember that minus sign will follow it as a negative sign right there, okay? So that's a negative 0.125 times 80x. That'd be negative 10x right there. And then distribute to the negative 7. Would give us, that's going to be positive now. That's how many x's there are, 0.875 x's, okay? And then we got this equals negative 46. Now, I didn't point this out, although some of you may have noticed, and you could have done this. These two are like terms in the parentheses. You could have combined them. Does that make it easier? I don't know, but you could have, okay? In any case, I will now look to combine the like terms. And, well, I got this x term, and this x term. Lots of x's to combine here. So how many x's is that? 0.125 x's minus 10 x's plus 0.875 x's. I get negative 9 x's out of that. Of course, the calculator would know better than I would, but I'm going to drop this negative 1 as well, as minus 1. Why do I have 2 x's there? I don't need 2 x's. Sorry about that. But this equals negative 46. Well, I didn't expect this to get rid of all the decimal, but I guess it did. In any case, principle of equality, I'm going to add 1 to both sides here to zero that negative 1 out. I'll drop my negative 9x, which now equals negative 46 plus 1. I get negative 45 right there. And now I will divide both sides by negative 9, yeah. I got x is 5. This is one of those key parts to a problem like this one that throws a lot of people off, right? Not the box, but the minus, especially with fractions that even if it's like 2 decimal places or 1, like that's, by the time you see this decimal, we've kind of forgotten about really the negative sign that's out there in the front. So yeah, you got to be very careful with that because that is a negative 0.125 because of that minus sign. We got some distribution we got to do first on this one, okay? Especially with that negative 0.4. It's negative, and we know it's negative because it has the negative sign, so we don't have to mix it up with that minus stuff, right? But negative 0.4 times 0.3 would be negative 0.12 n's. And then negative 4 times negative 0.2, that's going to be a positive 0.08. I'm showing the first 0 there in the front. You don't have to if you don't want to, okay? And then, of course, it still has the minus n there, that's on the left. There is some distribution on the right with the negative 1.1, which we can do. So negative 1.1 times n, or 1n, would be negative 1.1n. And then negative 1.1 times negative 0.1, that's a negative and a negative, which makes a positive. Well, 0.11 on this, okay? Of course, still minus 3.2. So there's some distribution. We do have some like terms to combine. On the left, I got some n's. Negative 0.12n and then negative 1n. these two are going to combine to give us negative 1.12n with positive 0.08, nothing to combine it with. On the right side, I don't have any other n terms to combine negative 1.1n with, but I can combine my positive 11 hundredths with the negative 3.2 right there. Okay, so looks like that's going to be a negative 3.09. I can do a better 9 than that sometimes. So I'll do this in 2 steps. I know in the last couple of problems I did it in 1 step, but 2 steps on this one, okay? So I want to put the n's on the left and then the numbers on the right. Not that you have to. If you put them on the right, you'll get the same answer. But I got to zero out that 0.08. So subtract 0.08. But if I do it to one side, I got to do the other side as well. Minus 0.08. So that does zero that out. I'll drop my negative 1.12 n's. We zero out the 0.8. This equals, yeah, we'll drop the negative 1.1 n, 2. And then negative 3.09 minus 0.08 should be negative 3.17 on there, right? So now I got the purple negative 1.1n. We got to zero that out too, so we'll add 1.1n. But if you do it on one side, you got to do it the other side as well. Kind of line up the decimal places there. That's going to zero that out. So what do we get on that one? A negative 0.02 n. Okay. And then on the right side, we still have that negative 3.17. I'll just drop that over here. Final step here. Yeah. Just we're going to take, so let me do it. I'm going to take that negative 0.02 and divide it by itself to make a phantom 1n, which is what we do want. But if I do it to one side, I got to do it the other side. Now, some of you may be able to do that in your head. I cannot, so I'm going to do this on my calculator. 3.17 divided by 0.02, enter, 100, positive, by the way, 158.5. You want to put a 0 on the end of that, that's fine. Okay, let me check, because, I mean, that's kind of an ugly number, and the work is kind of ugly too, but let's find out. So I'm going to put this into the calculator. Now I'm going to use the x function on the calculator just because it's going to make this easier. So I have 158.5. If you look at the bottom left, it says on, and then right above it says stow. That's to store a value. So I push stow. You see the little arrow that pops up? Then right above that, there's the X button. So I push it, then I push enter. What I've just told the calculator is when I type in X, I really mean 158.5. And the calculator says, I can do it. So now I'm going to type in the original left side of the equation. So negative 0.4, open parentheses, 0.3, not n, but x now, minus 0.2, close parentheses, minus x. I push enter, I get negative 177.44. That's on the left side. Let's try the right side. When I do this on the right side, though, I should get the same value. So negative 1.1, open parentheses, x on the calculator, minus 0.1, close parentheses, minus 3.2. Enter, yeah, there it goes, matched, negative 177.44. So I can see that both sides were equal, and when I replaced the x value with 158.5, now that I've checked that, yeah, I can box that in, and wow, I can feel pretty good about that actually. Okay.